In this video, we are going to look at the large-scale manufacture of ammonia. Ammonia is manufactured in large scale through a process referred to as the Haber process. This process is a process that leads to manufacture of ammonia. For Haber process to proceed, we require the raw materials for the process, the conditions for the process, and finally the steps of that process. So for our case, Haber process requires nitrogen gas and hydrogen gas. So this nitrogen gas can be obtained through fractional distillation of liquid air, whereas hydrogen can be obtained through the thermal cracking of long chain alkanes. Now from the raw materials we move to the conditions. The first condition is a temperature of 400 degrees Celsius and 400 degrees Celsius to 500 degrees Celsius. Then we have the pressure. It requires a pressure of between 200 atmospheres and 500 atmospheres. Finally, the final condition is it requires a catalyst. It requires a catalyst. And for our case, for Haber process, we are going to use a catalyst which is referred to as the finely divided ion. That is the catalyst for this process. We are going to use the finely divided ion. So after the conditions, we now look at the steps that involve the Haber process. The first step for Haber process is the two gases, that is nitrogen and hydrogen, are passed through the purifier. That is to remove, the function is to remove impurities. It is to remove impurities which would have poisoned the finely divided ion, which is our catalyst. So impurities such as dust, carbon 4 oxide, and sulfur 4 oxide are removed in the purifier. The gases are then pumped into the compressor, where the gases are compressed to a pressure of 200 atmospheres. Then after compressing the gas to a pressure of 200 atmospheres, it is then pumped to the heat exchanger, where it is preheated to a suitable temperature. Then the two gases are pumped to the chamber, which has got a catalyst, which is the finely divided ion. The catalyst is the finely divided ion. In the catalytic chamber, the mixture of the two gases are heated up to a temperature of between 400 degrees Celsius and 500 degrees Celsius. So here, after the gases have attained this temperature, they are then passed over the catalyst for them to react. That will lead to production of ammonia gas. So the equation at the catalytic chamber will be nitrogen gas plus hydrogen gas will obtain ammonia gas. So to balance this one, we put 2 there. That one is balanced, that is nitrogen. Hydrogen is 6, we put 3 there. So the equation is now balanced. Now, the equation will be production of ammonia gas and heat. So the heat produced in the catalytic chamber is then removed in the heat exchanger. That is, the gas, which is ammonia gas, is pumped back to the heat exchanger where it is cooled. Then finally, it is pumped to the condenser where it is condensed to liquid such that it will be collected in storage tanks. So in the condenser, ammonia gas is condensed to liquid. It is condensed to liquid, whereas the unreacted gases are pumped back to the compressor, where in the compressor they will then combine in the catalytic chamber. So here the heat that was obtained from the hot ammonia gas will be used, it will be used to heat the gases that will be brought in. That is, the heat will be used to minimize the cost of production. That is why we recycle the heat, whereas here in the condenser we recycle unreacted gases that will lead to low cost of production. We can summarize the whole process by use of a flowchart. Now let us draw the flowchart. Now, the raw materials here is nitrogen and hydrogen gas. The gases are pumped into the purifier. In the purifier, impurities are removed, for example, carbon dioxide, dust particles, and sulfur 4. From the purifier, we move to the next step, which is the condenser. Sorry, not the condenser, the compressor. The compressor. In the compressor, here the gases are compressed to a pressure of 200 atmospheres and 500 atmospheres. So this one is purified air. No, purified nitrogen and hydrogen. Then after compressing the air, the two gases are then pumped to the heat exchanger. In the heat exchanger, it is preheated to a suitable temperature and then pumped to the catalytic chamber. Catalytic chamber. In the catalytic chamber, the two gases, the temperature is raised to a temperature of between 400 degrees Celsius. The temperature is between 400 degrees Celsius and 500 degrees Celsius. And in this catalytic chamber, there is a catalyst. We have a catalyst, which is the finely divided ion. So after raising the temperature to a temperature of between 400 degrees Celsius and 500 degrees Celsius, the two gases are then passed over the catalyst, that is the finely divided ion, for us to obtain ammonia gas. So the equation here will be nitrogen gas with hydrogen gas. We will have ammonia. We will have ammonia gas plus heat. So here we balance the equation 2 and we put 3 there. So the gas that was produced is then pumped back to the heat exchanger. So here we have ammonia gas with heat. So here the gas is cooled and pumped to the condenser. So here we finally have the final step, which is the condenser. So the gas, the cool ammonia gas is pumped to the condenser, whereby in the condenser the gas is condensed to produce the liquid ammonia. So here we'll be having liquid ammonia. That is, the liquid ammonia is our product, whereas the unreacted gases here are pumped back to the compressor. So here we have unreacted gases. Then from this step, we can see that to obtain high yield of ammonia, we must meet the optimum. We must meet what was the optimum conditions. The optimum conditions for this process is a pressure of 200 atmospheres and the presence of a catalyst, which in our case is the finely divided ion. And finally, another optimum condition is a temperature of 500 degrees Celsius. Those are the optimum conditions that will lead to production of ammonia in large scale. This one will lower the cost of production. So for high yield of ammonia, we will have a high pressure and low temperature. So high yield of ammonia will require, for us to obtain high yield of ammonia, it will require a high pressure and a low temperature. That will lead to production of a high yield of ammonia. So you find that this ammonia, it can be used in the manufacture of ammonia. The uses, we have at least 2 uses of ammonia. This one, it is used in manufacture of nitrogenous fertilizer, and also it is used in water softening. Thank you for watching this video. Please like, share and subscribe.